Good morning friends. I am Chetan Devidas Ingale, working as an assistant professor in Department of Chemistry, RBNB College, Shirampur. In our previous lecture, we have studied how to prepare alcohol by using grignard reagent. For example, by using formaldehyde, we have prepared primary alcohol, whereas by using aldehyde with grignard reagent, we prepare secondary alcohol, and finally by using ketone molecule, we prepare tertiary alcohol as a product. Now, in this particular lecture, we have to see how grignard reagent reacts with ethylene oxide and ester. Okay. Now, in this particular lecture, we have to see the reaction of grignard reagent with ethylene oxide. We know that ethylene oxide is nothing but epoxide, and when this epoxide is treated with grignard reagent like methyl magnesium bromide, the nucleophilic part of this grignard reagent attacks on one of the carbon atom of this epoxide, because the epoxide ring has a ring strain. That's why this nucleophile will easily attack on the carbon atom, one of the carbon atom of this CH2 group, to relieve from a ring strain. When this happens, this CH3 group add on this carbon atom. Which on hydrolysis gives N-propyl alcohol as a product. When we carry out a reaction on epoxide or ethylene oxide, it is the unsubstituted ethylene oxide. That's why the attack of nucleophile takes place on either carbon atoms. But instead, if we use the sterically hindered ethylene oxide, it means when we carry out the same reaction on substituted ethylene oxide, the product will be different. If we carried out the same reaction, but instead of unsubstituted ethylene oxide, if we use substituted ethylene oxide as a substrate, then what happens? We have to see that if this is the substrate and this substrate is treated with this same grignard reagent, that is methyl magnesium bromide. Now, in this reactant, we observe that there are two different sites on which this methyl group going to attack. Now we know that this is more substituted site. As being the more substituted site, it means it has a bulky methyl group, that due to that bulky methyl group, this carbon atom becomes sterically hindered, and this due to this methyl group, as it becomes sterically hindered, the attack of this CH3 negative on this carbon atom becomes difficult. Hence, in such cases, methyl group always attack on the less substituted carbon atom and the product will be formed as a secondary alcohol. Instead of our primary alcohol. This is all about the reaction of ethylene oxide with grignard reagent. Now, the same grignard reagent, when treated with ester molecule, what happens? Then for that we have to see reaction with ester. Now it is the simple reaction in which when ester molecule, for example ethyl formate, when treated with methyl magnesium bromide in excess, then in first step we obtain aldehyde as a product, that is HCOCH3. If we use our ester here, ethyl formate, and methyl magnesium bromide, that is our grignard reagent, in equal amount, that is 1:1 proportion, then the reaction stops at aldehyde level. When we use this grignard reagent in excess, then the reaction stops at alcohol level, that is formation of secondary alcohol here. When we use what? Excess amount of methyl magnesium bromide, in first step ester gives aldehyde, and in second step the excess, the remaining molecules of methyl magnesium bromide attacks on this aldehyde to give secondary alcohol as a product. This is the second reaction, that is reaction of grignard reagent with esters. Okay, now the next reaction is nothing but catalytic reduction. Now we know that what is meant by catalytic. Catalytic is nothing but in presence of catalyst. Generally, for this catalytic reduction, we use some reagents or catalyst like nickel, palladium or platinum. Generally, Renyi nickel is used for such catalytic reduction when aldehyde molecule is subjected to Renyi nickel. When this acetaldehyde, for example, this acetaldehyde molecule is subjected to Renyi nickel at 140 degrees Celsius, this Renyi nickel converts this aldehyde molecule, here acetaldehyde molecule, into alcohol, that is our ethyl alcohol. ethyl alcohol. This is the only reaction. Now, this catalytic reduction has a greater utility to reduce alpha beta unsaturated carbonyl compounds. For example, alpha beta unsaturated aldehyde molecule. Now, when this alpha beta unsaturated molecule, that is aldehyde, when this alpha beta unsaturated aldehyde undergoes catalytic reduction by using ranitidine, this ranitidine reduces this carbon-carbon double bond along with this aldehydic moiety. Now, look at the product. It will convert to one butanol. This is the product of this reaction in which this ranitidine reduces this carbon-carbon double bond as well as this aldehydic functional group. This is the first application of this catalytic reduction. Now, instead of catalyst like palladium, platinum or nickel, if we use sodium amalgam in presence of water or acid, that is reaction with sodium amalgam in presence of what? In presence of water and acid. When we use this sodium amalgam, that is NaHg, with water, the reaction between these two gives NaOH, mercury and nascent hydrogen Now, this nascent hydrogen will be used to reduce aldehyde or ketone. When it reacts with aldehyde molecule, obviously it gives primary alcohol, and when this nascent hydrogen is treated with ketone molecule, then we obtain secondary alcohol as a product, as seen in our example. When this propanaldehyde is treated with sodium amalgam, that is NaHg, in presence of water and acid, we obtain what? 1-propanol as a product. We obtain what? 1-propanol as a product. Now, the next reaction is nothing but preparation of alcohol by using lithium aluminium hydride, that is LiAlH4. This lithium aluminium hydride is the strongest reducing agent. It reduces almost all functional groups except carbon-carbon double bond, that is alkene. Now, we know that lithium aluminium hydride contains hydride ion, and carbon-carbon double bond, that is alkene, also has a pi bond. It means it has pi electrons. That's why due to the pi electrons, that alkene becomes resistant to electrons. That's why hydride ion from lithium aluminium hydride cannot attack on the carbon-carbon double bond, and that's why lithium aluminium hydride cannot reduces carbon-carbon double bond, otherwise it will reduces almost all functional group. We have only 2 applications of lithium aluminium hydride in this year. Out of these 2, the first one will be the reduction of aldehyde and ketone. When this acetaldehyde molecule is treated with lithium aluminium hydride, which cannot be used with protic solvent, because when it used with protic solvent, it liberates hydrogen, due to which there is a chances of catching of fire. Hence, when this lithium aluminium hydride, it can be also written as lithium aluminium hydride. In first step, generally lithium aluminium hydride has 4 hydride ions. That's why to maintain this stoichiometry, we have to use 4 molecules of acetaldehyde. Now, we obtain this molecule as an intermediate, which on hydrolysis gives 4 molecules of alcohol with the liberation of AlCl3 and LiCl. This is the first application of lithium aluminium hydride. This is the first application of lithium aluminium hydride. Now, when this same lithium aluminium hydride is treated with carboxylic acid, that is reaction with carboxylic acid, when this lithium is treated with acetic acid, it is an example of our main reaction. When this carboxylic acid is treated with lithium aluminium hydride, we obtain intermediate like which on hydrolysis further gives primary alcohol as a product. Generally, this lithium aluminium hydride is used with non or aprotic solvent. Generally, it is used aprotic solvent like diethyl ether. This is all about the reactions of or the preparations of alcohol by using different methods, like preparation of alcohol by using grignard reagent, preparation of alcohol by using catalytic reduction, such as by using catalysts like palladium, nickel or platinum. The second catalytic reduction is by using sodium amalgam in presence of water. And finally, preparation of alcohol by using lithium aluminium hydride. This is all about the preparations of alcohol. Thank you.